today's topic is, data governance on top of your Lakehouse with Databricks. You're probably already aware of the Lakehouse paradigm and the architecture that we're pushing at Databricks, on which you're basically combining all the benefits of a data lake and an enterprise data warehouse into just one single unified architecture based on open standards. And obviously, one of the questions we're getting quite often is about data governance. And when you're moving forward with such an architecture on which you're getting all your workloads from classic ETL workloads, as well as BI workloads, data science and machine learning workloads, and so on, into just one single unified view, you need to enforce the proper data governance. And at Databricks, when we think about data governance, we're basically covering four main areas. The first one is data access control. Who has access to which data sets at which moment? Some groups could have access to just a subset of the information. Some other groups could have access to all the information. Some groups could have access to masked information, an anonymized one, for example. And that's obviously one of the most important aspects of data governance. Data access audit, capturing and recording all the access to all the data sets, making sure that we can revert back in time, see who did what at which moment with the different data sets. Data lineage, which is, of course, a really important aspect of it. And, a lot of technologies are actually already focusing on lineage. If you were a Hadoop stack users in the past, you probably heard or used, Cloudera Navigator or Atlas, for example. Or if you also, had an enterprise-wide metadata management platform, you are probably doing end-to-end data lineage. So the purpose of lineage is really to capture the upstream and downstream sources and consumers, basically going at an attribute level, seeing the operations in between, and understanding what type of modifications you will do and perform on top of your data. And of course, with this kind of capabilities, you will be able to do impact analysis. Okay, if I'm changing this specific delta table or the schema of this specific table, what will be the impact of my overall chain of ETL workloads and so on. But you will also be able to do lineage analysis, for example, just going on a classic BI report, on your Tableau report, and validating from which specific table this information is coming from. And finally, data discovery, on which you will be able to search and discover across all the authorized assets for a specific information. Yeah. So basically at Databricks, we wanted to create an open and unified approach to cover all those four areas, which is what we're calling the Unity Catalog. It will offer fine-grained governance for both data and AI on top of your Lakehouse. Number one, it will unify governance across clouds, and that's a really important aspect. If you're actually leveraging Databricks on multiple clouds, you will be able to unify your data governance with Databricks. It will be fine-grained, so you can go up to an attribute level, up to user level, and so on. And it will be based on standards. So we really relied on ANSI SQL to create all things about data governance, because everyone knows ANSI SQL. It's a just well-known way of doing things and so on. So we didn't want to recreate something from scratch with a language like a Databricks-specific language. All standards as usual with Databricks. It will unify data and AI assets. So you will be able to centrally share, audit, secure, manage all data types with just one simple interface. And more important, not only data, but also other assets like models, for example. You will be able to govern models the same way that you will allow an access to a specific data set. And finally, because a lot of customers are actually already leveraging existing catalogs, we really wanted to make sure that this Unity catalog is open with all the APIs available, so you can connect with existing ones, works in concerns, in concerts with those existing ones. And you do not have to do a hard migration if you're already leveraging a catalog to use it with Unity. So in a nutshell, the UI, I will say, it's still a work in progress. We're still testing it with customers. And obviously at Databricks, the way it works is that we're getting a lot of feedbacks from customers. So we might revise a little bit the way the UI is getting landed right now. But it should look a little bit like this one. Like you will have data discovery, access control, data access audits, and data lineage available for you in a specific UI. And you can see here that you basically have the name of the table, the description, that is basically the business semantic around your data, all things about data access control, and basically Unity Catalog will allow you to do role-based access control, creating like a PII specific information that you will then tag to different attributes across different tables to give you an idea. Data access audit, pretty straightforward, just validating who had access to what in the past and so on. Data discovery, that will search across your different data sets for similar information or whatever type of information you want to look after. And finally, lineage. And this one is a really, really simple one. But again, you could think about lineage as an end-to-end process across all your Delta tables, both upstream to downstream, and like impact analysis to the upper business level, if you will. So, of course, Unity Catalog is coming with a set of principles. And the first one is the define once, secure everywhere. And you saw it from the previous slides. We really wanted something multi-cloud, multi-workspaces, and standard. That's kind of the fourth point here. So you define it once, you secure everywhere. It's not just one single workspace. You can actually do it at a master level, and all the workspaces around, no matter if they're running on the same cloud or on multiple cloud, will benefit from this governance. It will be user and group centric, and actually the grant you will do on data will supersede your classic cluster role-based access control. It will allow fine-grained security at a row, at a column level, and to an extent at an attribute level as well. Not now, but it will arrive in the future. It will be standard. Touch this one. You will have capabilities of data lineage, so you will know the impact before changing, or you can go at a high level and see what's going on when you're using this kind of information. And finally, data discovery capabilities that will allow you not to recreate everything, but just search for a specific data set before you're creating a new data set or you're creating a new ETL workload. So when we're saying define once, secure everywhere using standards, you can see actually how we will do it using ANSI SQL. Again, centralized governance, open standards. So here you're creating a table. You will grant specific access to specific groups. You could go up to specific attributes, for example. And moving one step forward, when we'll start to play with attribute-based access control, you will actually be able to create an attribute. And in this case, the attribute is personal identifying information, which is the number one GDPR attribute that you want to tag all your data sets if something's happening. And then you will be able to just alter all the existing Delta table with this attribute. This way, instead of granting access to every single tables, you will just go do it at an attribute level, and all the tables using this attribute will inherit from this rule out there. And again, it's all SQL based. So here's the permission level on the table, which is at the end of the day a collection of files, in your favorite file storage, no matter that you're using AWS, Azure, or Google. And finally, it's completely synced with your users and your user groups from your identity providers. All right. So I think we can pass on this one. You already saw it, the attribute-based access control. I'm creating an attribute, then I will alter the table with this attribute on all relevant informations, and then you will deal at an attribute level for all your governance. So of course, there's a benefit of doing it at such a level. The first one is it's completely uniform. So you will secure an enforced access for any type of user codes, no matter you're dealing with SQL, Python, Scala, Java, R, or any kind of libraries. Well, no users will get access to the raw data or directly to the credentials. Databricks will use either filters tables or give short-lived tokens with a timeout. So you will be able to get access to the data, and after a while, it will just be revoked, so you don't have access to it. So technically wise on the process, that's the way it will go. You're requesting a select on the table event in this case, and then you will come back with an approved like temporary token, and then you will be able to read the table for the duration of the token. The second aspect is lineage. I touched kind of like in a lineage already, but just wanted to give you an idea. The challenge of lineage is obviously how you will harvest metadata out of your different workloads. And think about it. In Databricks, you could actually have Scala notebooks, you can have Python notebooks, you can have SQL notebooks, you could use like libraries and so on. So how would you just extract all the lineage information from such a heterogeneous like environment? That's where the notion of auto capturing comes into the picture. And obviously, you probably had a session on Delta Live Table in the past. Obviously, lineage will work natively with Delta Live Table. And based on the annotation and the information across your ETL, refining workloads and logic, all those metadata will be harvested and will be used to recreate the lineage. In the idea, the lineage will go down to the table and a column level, and you will leverage a common permission model from Unity Catalog here. So it's not yet available, even on the private preview. We're doing a lot of work right now to make it available, but that's the idea behind it. So you're prepared on what's going on next. Of course, data lineage is super important, and the number one reason is compliance. Any kind of like regulatory environments, we have to deal with heavy compliant rules and like, okay, well, can you please identify all your PII informations across all your lakehouse, like all the tables that you're dealing with, track the spread of those sensitive data across data sets. If we move one step forward, for example, with GDPR, having the right to delete a subset of information related to this specific attribute out there. Of course, discovery, you will be able to understand the context of data before recreating a notebook from scratch or creating a logic from scratch. You will be able, by having all those lineage information, to search across all the data sets available and prevent duplicative work, not having to recreate the same logic again and again, just looking and searching for the data sets and ideally the ETL or whatever type of workloads, and then we use them. Metadata observability is also a third aspect, which is really important here. Analyze the impact of the changes to downstream reports. That's a pretty common one. If I am modifying this specific delta table, for example, or I am removing a column or whatever, what will be the impact at the end of the chain on Tableau reports and so on? And finally, track down issues in reports by tracing back the data the other way around. So data lineage will technically wise look like this one. You got different building blocks on the left side, like you could have like ETL jobs or ad hoc code that you're running against the clusters, or Delta Live Table process that you're having here. And basically every single code will be submitted to a cluster or SQL endpoint. And you will have a side of that a lineage service. And this lineage service will basically analyze all the logs from the cluster and pulls all the metadata from Delta Live Table. And by doing this, lineage service will be able to rebuild a complete picture of the sources and the targets and all the ETL modifications in between up to an attribute level. And finally, this lineage will be presented to the end user in a graphical manner. And more important, obviously, you will be able to access this lineage not only on Databricks, but if you're dealing with like a Colibra or an enterprise-wide metadata management tool, you will be able to harvest the metadata, connect to our lineage service REST API, and extract the metadata out of it. Yeah. So again, that's still high level. We're just giving you like the way we're getting it implemented right now. Stay tuned. The next couple of months, you will basically see it arriving more and more with like private and then public gated previews, and you will be able to test it out directly in your environment. So again, table and column level, that's actually like, just schemas, but to give you an idea, the table one is easy to do. The column one is not that easy to do, especially if you're using like specific libraries that will deal with like different columns within your data sets and so on. So that's where we are right now. We're just evaluating different ways to do things, working with partners and so on. And obviously, if I go back to this architecture here, DLT will have a significant play here, because on DLT, you will have this information directly within the code. You're kind of creating and building your workflow directly at a notebook level to an extent. So it will be easy to harvest metadata. Whereas on the other side, like running ad hoc code directly in your cluster will result in a more complex harvesting logic. So I mentioned this in the past, but obviously not everything is a Delta table, especially on Databricks. You got a lot of data science users that are actually dealing with the model and models, right? So same thing here. We wanted to offer the same way of governing assets using good old NC SQL. And you can see here that we're actually granting a specific right on a machine learning model. Underneath this, we'll use like MLflow and our Unity catalog and so on. But we really want to have the same syntax here. Yeah. So I really want to insist here, every single asset that you will deal with within your entire lakehouse will be governed in the same way using the same syntax. So how does this interact with security partners? Obviously, we do have a lot of customers that are dealing with great companies like Immuta or Privacera, which are also offering similar capabilities as well. So obviously at Databricks, we really wanted to have an approach where you could just work together. You don't have to replace all the work you have done in those third-party software into Databricks, but instead will be natively integrated. So we're already working with Immuta and Privacera, not only exposing the APIs on our side on the Unity catalog, but making sure that they're kind of natively integrated. So it will be easy for them to push like some policy specifications, for example, that will then be converted in good old plain NC SQL and enforced at a cluster or a SQL endpoint level if you're dealing with Databricks SQL. Okay, so it's just improving the experience with Immuta and Privacera. There's no limits on the way you will use APIs. And of course, it will improve performance and robustness because you will all go directly through Unity catalog, and it will be just plain old governance using ANSI SQL at the end of the day. All right. So before we move forward with a demo, we have actually created a pretty cool demo that Leon will present right now. But I just wanted to do a quick recap on Unity catalog different features. Data access control, you define once, it's secured everywhere, across clouds, across workspaces, across languages. Audit capabilities, on which you will see exactly what happened in the past, being able to do like fine-grained audit for all queries and so on. Data lineage, data discovery, and finally, attribute-based access control that will arrive later on. The two features that are within the private preview, which is occurring right now, are actually data access control and audit capabilities. But obviously, our goal at Databricks is just to cover all those areas as I mentioned, and this will going to arrive in the next couple of months. Awesome. Leon, over to you, mate. Can you drive us through a full end-to-end demo?
Yep. Thanks, Amine. Yep. So I'm Leon Eller, and my role at Databricks is I'm AWS Partner Solution Architect. So I specialize primarily on AWS. So let me just share my screen, and we'll dive straight into the demo. All right. So as Amine mentioned, the Unity catalog is actually across multiple workspaces, and eventually will be across multiple clouds as well. So you will basically have a single Databricks account through which you log in, and you'll be able to then access compute in different clouds. So you'll have like a single view of all of your accounts and from different cloud vendors, and ability to then run workloads from a single account, single UI. That's coming in the future. We do have a Databricks account console today. That only exists on AWS. I believe it also exists on GCP. In Azure, it's a first-party service, so it's basically integrated into the Azure portal. But in AWS, it's a separate account console. And what I'll demonstrate for you now is how Unity configuration and how that fits into the account console and how it's actually shared across multiple workspaces. So the setup here is I've got two workspaces. AME stands for American Workspace, and EMEA stands for European Workspace. So they're two independent workspaces, two independent URLs. They want to be able to access the same data, so the same storage location, but you want to be able to configure permissions to the tables and to the data itself through a single Unity catalog, right? So Unity catalog exists across multiple workspaces, and you can go into the Unity catalog and start defining permissions through that mechanism. Now, what I'm going to demonstrate is there'll be three separate groups. So there will be a group for EMEA user called EMEA group. There'll be a group for EMEA user, EMEA group, and then there'll be a group for admins called Metastore admin users. And so the idea here is that admins will have access to see all of the data, including all of the objects in the catalog. And then you've got different users. So EMEA user is only allowed to see data that belongs to their region, and EMEA user is only allowed to see data that belongs to the EMEA region. Just to give a quick overview of what the Unity catalog model looks like. So at the top level, you've got a catalog, and below that, you've got database or schema. And then below that, you've got various objects in your database, so tables, views, functions, etc. And you can define permissions across all of those. And I think Amin's already gone over this. Basically, the way the permissioning works is fine-grained access to tables, views, etc. is governed by the Unity catalog, but then Unity catalog integrates with cloud-native IAM permissioning. So in this case, it's AWS IAM role specific. So you can define, when you configure access to data, you define also, and I think Amine showed you the SQL statement for that, you also define which particular, in AWS context, which particular IAM role should be assumed to access the data that exists on S3, for example, right? And when assume role API is called, a short-lived token is generated, and then that short-lived token is used through the URL to access the data. So all of that is governed differently to the way, let's say, table ACLs are done today. So if you're familiar with table ACLs, the difference you'll see here is that with different independent workspaces, if you just use the Hive Metastore out of the box that exists in the control plane, you have a different Hive Metastore for different workspaces. You can create an external Hive Metastore and have it shared between workspaces. And also in AWS, for example, you could use Glue as your central catalog. However, currently, table access control permissions are not shared across workspaces. They are defined per workspace. Whereas with Unity catalog, you can define it at the global level. Okay, so let's dive into the actual demo. So first, I'll go to the account console. So this is what the account console looks like. So here, it's centralized URL. I'm just logging into that, and I'm able to then define my users and my groups. So in here, as I said, I've got 3 different groups. So if I search for a EMEA group, there are all the users in there, and the user that I'm going to be using is this one here. So I've created a special user. This is the EMEA user who's only allowed to view American region data. Then if you go back and look at the EMEA group, I've got another user here who's only allowed to view EMEA data. And then if we search for Metastore admins, I've got an admin user here as well, who is obviously allowed to view everything. So you'll notice one difference here is I'm defining groups that will be permissioned against in the data by Unity catalog at the account level. So I'm no longer doing it in the workspaces because workspace model is local to the workspace. I'm doing it at the account console level. Okay, so I've defined all those groups. Great. So now I'm going to log in which I already have done, to the Amir workspace. So you can see here in the URL, it says Amir. The account I'm using is the admin account. You can see down here. So what you'll see here is you're probably familiar with the 3 different personas for accessing Databricks, data science and engineering, machine learning, SQL. I'm actually in a SQL pane here, and I'm able to access and I'm able to view permissions as well as the whole catalog from there as well. So if I click over here, you can see I've got 3 different catalogs: Hive, Metastore, Samples, and Main. And Main is the one I'm interested in. Now, you'll notice here that I've got 2 different databases: TPC-H database, which is used for TPC-H benchmarking, as well as retail restricted. So before I actually start running queries, let me dive into how you actually define permissions using SQL. So you can see here, I'm just in a notebook. And in here, I just say, I want to use this main catalog. You'll also notice that, and this is currently available for table access control permissions as well, is ability to understand the person who's running the query, whether they're a member of a particular group. So if I actually run this, so currently I'm an admin, so it's telling me that I'm a member of Metastore admin users group. So you can use this mechanism, and I'll show you that in a minute, for defining dynamic views. And even though we don't have attribute-based access control today, so that's coming in the future, early next year, you are still able to define row level and column level permissions using dynamic views. Obviously, with attribute-based access control, it will be completely declarative, and you'll be able to do it through Unity Catalog directly and define various behavior based on the policy of what a particular role is allowed to do with the attributes, or whether they're allowed to view it, or whether they're not even allowed to see the column, or whether the column appears as redacted, the value appears as redacted, or just hashed, etc. So before I go here, let me actually go to a different notebook. And you can see here, these are the statements with which you can grant permissions to various objects within Unity Catalog. Right? So I'm granting usage to catalog main to group EMEA. So this is so that they're able to even access this catalog. And then I'm also granting them access. So this is both EMEA and EMEA groups. So I'm not granting access to users here, I'm granting access to groups. And here I've defined some views, and I'll come back to these dynamic views in a minute. And I'm saying EMEA group has select permission on this view. EMEA group also has select permission, etc. Right? So that's simple grant deny statements that you can run to apply permissions to various objects within Unity Catalog. And of course, once attribute-based access control is in the picture, Amine has shown you different statements for how you can actually assign attributes and define permissions based on attributes on different objects. So similar thing happens. So I've got 2 separate data sets, as I said. Similar things happens here, where I've granted select permission to different views. Now, if we look at what's happening within the views, so these are what's called dynamic views. So within my data set, it's a retail data set, and within this retail data set, I've got some columns that define the particular region. And so if you remember, I've got EMEA and EMEA groups that I've defined. So by running this isMember on the actual column value itself, that allows me to perform row-based access control. So I'm saying that if the value in that state, if that's EMEA, and the user running the query is a member of that group, then they're able to see this row. If not, that row gets filtered out. And also I'm saying here that if they're a member of the admin group, by default, they should be able to see it. Now, if I want to then do something with columns, what I can do in dynamic views is I can use this case when statement. And again, I'm saying here that if the user running the query is a member of the admin group, they're able to see the value in customer city column. Otherwise, it appears as redacted. Yeah. And similar thing over in the TPCH data set. I've got a column called team owner with the AMIR or AMIR value in it, depending on which region the row belongs to. And again, if the user is a member of that group, they're able to see the row, otherwise not. And additionally here, I've got column-based hashing. So if the user is a member of the admin group, they can see the address, otherwise the address gets hashed. And so you just get to see the hash of the value. Okay, so that's pretty much, how you sort of assign access control. Now, another way you can do it at the database object levels, if I go to Databricks SQL view, back to Databricks SQL view here, what I can do here is if I select customer, not here, I have to go to data. Yep. So here I can actually navigate through my catalog. If I click on customer, you can see I've got additional things I can do here. So for example, I can see the schema of this data. I can go and extract a sample. The details in terms of, what kind of properties are exist on the table, and any other kind of metadata that's associated with the Delta table here. And I can also see permissions. Now, admin group is the owner of this table, so no other permissions are allowed. But if I click on the view, you can see here that I've granted select privileges, which you saw in the notebook that I just showed you. I've granted select privileges to both EMEA and EMEA group. And I can go and do it directly from the UI here as well. So I can select what privileges I can grant, which user or group I should be granting it to, etc. Now, the other thing I can do here is if I click on history. Okay, that's not a Delta table because it's a view. So we'll go back here. So I can directly see the Delta log output here as well. So I can see who's performed what action, what kind of transactions have been performed. So I can actually navigate through this in the UI as well. So now, if I go to the actual query, so let's go to this one, for example, and let me take that out. So I can run this query. And in the output, you can see that I'm able to see all the different regions because I'm an admin user. I can see all the different regions. That's not being filtered out for me. And I can see all the values in all the columns. Right. Customer city appears here for me, so I can actually know what the city of the customer is. Now, if I go and switch to a different user, so let's go to a EMEA user, for example. So here you can see it's the same EMEA workspace. The URL is the same. If I click on, the user, which user I'm actually logged in as, I'm logged in as a EMEA user here. So I'm not an admin anymore. So now if I browse through my data, what do I get to see? Okay, let's have a look. Okay, all I actually get to see are the views for which I've been granted select permission. And similarly, if I go to read or restricted, I'm only able to see those views. I'm not able to see anything else. And I'm only able to see permissions that have been granted to me. I'm not able to see any other permissions to other groups that I'm not a member of. Now, if we go to the query itself, okay, so I'm going to run this query here. Let's see what happens. So you can see here that the customer city appears as redacted. So if you remember, I showed you the case when statement where I said if somebody is not a member of the group or the state, the value in the state, the output should appear as redacted. You'll also notice that I'm only seeing American regions. There's no EMEA regions here. Similarly, for the actually, what's this one? Yeah. So if I actually join with the region table, we can see I'm only seeing EMEA, and if I actually to make sure, I say state, or the B state equals to EMEA. That I see nothing because I'm not allowed to see anything else. So similarly, if I now go and switch to EMEA user, which is right here, you notice I'm still in EMEA workspace, but now the user is EMEA user, different user altogether, member of a different group. I can still navigate through things that I'm able to see in terms of database objects. So only views you can see here. That's all the permissions I've got. So then if I go to the query and run the query again, so now I'm only seeing EMEA. And again, to make sure, we will filter it out. Auto in that. And we can see nothing comes back. And you'll also notice that the value comes out as redacted as well for the CD. Yep. Now, if we actually run this one, which is a TPCH view that we've defined, if you remember, I made address hashed, and you can see here you get the hashed address coming out. So Unity Catalog is currently in private preview. So over the next months into early next year, we'll be adding more and more features into the product. I think it's about to go to gated public preview as well. So at this stage, there is no attribute-based access control. There's currently no lineage, but lineage will be coming before attribute-based access control. But yeah, eventually, once all the features are in, everything, or the whole deck that Amine went through, all the features that are there will be available in Unity Catalog, and there will be UI available for you to define permissions at the global level. So you saw that I'm doing it across multiple workspaces. If I actually switch to another workspace, this one is a EMEA workspace, different URL. I'm logged in as a EMEA user. I can still see the same objects. I didn't have to define permissions all over again for these objects. I've defined them once, so that you can see there's additional catalogs in there as well. So the same permissions that I've defined are available here, and the same query that I was able to run before, I can run here again and get the same result back. Yeah. So that's all I've got in terms of the demo. If there's any questions, happy to answer them.
Thanks, Leon. That's just an awesome demo. I think Jonathan is asking about the additional costs of Unity Catalog. Like how will it be priced? I don't know if we are finalized on this yet.
Yeah, it hasn't been finalized. There is not a lot of clarity at the moment whether it's going to be a separate SKU, in which case they're going to charge extra for it, or it's going to be part of some. We've got different sort of tiers here. We've got standard, premium, enterprise, and whether it's going to be part of like additional features will be part of kind of a later other tiers, like enterprise tiers perhaps. So there's no clarity around that, but yeah, there's probably going to be additional charge for it.
At least for the advanced one.
Yeah.
Maybe the basic features will be embedded as usual. And for the advanced one, like Lineage++, we might have a separate SKU or a need to have like an enterprise tier. Don't know yet.
Yeah.
Are there any other questions from Amine or Leon?
More of curiosity than anything, but how do the column level lineage, how's that going to be implemented? I guess like that's super tricky to map from like table A to transform to table B.
Yeah, so yeah, that can be tricky. Now, if you're just running SQL under the covers, what the first thing that happens in Databricks runtime is a plan gets generated. Now, once a plan is generated, they will be using the plan to determine the lineage graph. Of course, if you're using UDFs and things like that, the only thing they'll be able to tell is something goes into UDFs and something comes out of UDFs, but they can't obviously tell you what transformation has occurred inside the UDF. But anything running at SQL level for which there's a plan generated, and this is across both Delta Live tables as well as standard workloads, there will be lineage information generated at column level as well. I don't have full clarity about where the limitations will be. There probably will be some limitations. As I said, UDFs is likely to be one limitation because it's a black box, right? If you define UDF, it's just a black box. But there definitely will be lineage information for all the workloads.
Yeah, that's really cool. Like I feel like this is something that works because of the inherent design of Spark.
Yes,
the
exactly.
execution plan. So something else like the pandas data frame, for example, wouldn't have that ability to have the lineage.
That's right. And you can imagine other tooling that sits on top of database engines, for example, Informatica, right? Unless you can peer inside the engine, it's very hard to determine, or unless you're actually defining the workflow through the tool itself, it's actually very hard to understand lineage because you're not inside the engine itself. Whereas the advantage here is Unity Catalog can peer inside into the plan itself and determine the lineage information from that. And it will also be, by the way, it will also integrate with other tooling as well. So it will integrate with Informatica and other tooling through the APIs. They're currently in the process of talking to all the partners to make sure that everyone's aligned in terms of what API, the expectation in terms of APIs, and whether they're happy with APIs. The feedback from our PM so far, that Informatica is very happy with APIs and they're going ahead with integration. So if you're talking about kind of enterprise level, some customers kind of want to have enterprise level tooling. Obviously, Databricks will give you Unity Catalog from Databricks perspective. We cannot peer inside, other engines like Synapse or whatever, Redshift. But if customers want to have enterprise level, information across multiple data assets, multiple data engines, then Unity Catalog will integrate with those as well. But of course, if you're defining, unified data platform where you want everything to be done in Databricks, if you've got a Lakehouse kind of vision and you want to have data warehousing workloads as well as data engineering, machine learning workloads, all running inside a single platform, then obviously Unity Catalog will give you all of that information out of the box.
There's a question from Yusri around, is there any option to control retention or disposal of certain tables and databases?
As in time-based?
Probably ask Yusri to clarify.
Yeah, I imagine it's time-based retention. Is that like being able to get rid of data or tables? Is that
Leon, that's correct.
Yeah. So if you think of the way Delta works, Delta already has those sort of concepts kind of built into through this vacuum mechanism and retention of the log files, right? That you can configure and define. How far back in time do you actually want to have historical information available? And when vacuum runs, you can actually vacuum out all the data. But that obviously works on data which is no longer like previous transactions. If you want to define sort of retention policies, at the moment, nothing is built in, but one way to achieve that would be to use Delta cloning feature to be able to clone out data which is no longer, which you consider to be like older, clone it out into cold storage and have data that you're actively querying available in hot storage. So that's one way you could actually do it today, but obviously it's not out of the box, as in it's not integrated into the tool in the declarative way, but you could obviously write some logic to do that, because we've got the feature, delta cloning feature, which will let you do that.
Thanks, Leon. There's a question from Dave around, is the security defined applied across workloads against standard high concurrency clusters as well?
It will be applied across all. There will be, so obviously if you're running something like Scala workloads, it's if you're running more than one user on that cluster, then there's a potential, because you're running basically arbitrary code on the cluster, right? There's a potential that somebody could grab someone else's credentials. So from that perspective, there will be certain limitations in terms of what APIs you can use on the high concurrency cluster with Unity Catalog enabled. But if you stick to SQL, obviously, there's no limitations.
Thanks, Leon. I reckon we've got time for one more question, if there is anyone, in the next 20 seconds. Take that as no. Amine, Leon, thank you so much for your time this evening. We really appreciate it. Really appreciate you coming on to make the Melbourne Databricks community special. We hope to have you guys back in the new year to talk more about Databricks. Take care, everyone, and have a great Christmas.